Hello, my name's Mark and I like talking about computers. And in this video we're going to look at 10 deadly sins that COBOL programmers commit. Now I know what you're thinking, COBOL's a dead language. No, it isn't. There are still billions of lines of COBOL out there that will be around for many years to come. And even today, new code is being developed in COBOL and new versions of COBOL are coming out. So here are the 10 deadly sins I picked out.
So here are our deadly sins, and straight in at number 10, old commented code. Look at this source file. You see a lot of commented out code in here, code that's no longer needed. This program has most likely been changed because of changes in business rules or regulations. This code is never going to be needed again. So why is it hanging around? Look at this source module. You see a bunch of commented out assignment statements. We don't need them anymore. They refer to business rules that have changed. Look at this one. Again, it's a business rule that's changed, so we don't need it anymore. But look, it's even worse. The code that's left inside the red box was originally inside an if statement. And somebody just commented out the if and didn't bother to outdent or reflow any of the code inside the if. This is a nightmare when you're debugging. Don't do it. Commented out code makes your source files larger, more cumbersome to work with, more cumbersome to debug. And think about this. I'm using Visual Studio Code here, which highlights comments very clearly. But imagine if you're using an editor like Notepad. It may not be so obvious when a line of code is commented and not active, and you may think there is an issue with the code when there really isn't. If you need to get that code back, you have version control. Just pull it from a previous version of a file. When I was team lead, my policy was that when you made a change to a source file, the first thing you did was to remove any commented out code that was there. So you started with a clean source file. You would then make your change, and if you removed any code, you would remove it by commenting out. So the only commented out code in the source file after the change was code that was removed because of your change. So get rid of that commented out code. At number 9, sections. Specifically sections in the procedure division, like this. Once upon a time, sections were needed to group paragraphs together. But nowadays COBOL has much better ways of laying out the program flow. Sections are no longer needed and are at best documentary. So let's give sections the old heave-ho. At number 8, exit just on its own in the procedure division. This is a no-no. Why? Take a look at this code. You'll see here that there is a paragraph 2000 exit. It just has an exit statement, and the exit statement is doing nothing because you've not specified what you're exiting. Exit on its own does nothing. When you use an exit statement, you must always say what you're exiting, just like this. So exit paragraph exits the paragraph, exit perform exits a perform loop. That's like breaking out of the loop. And exit perform cycle skips to the next iteration of the loop. So that's kind of like the continue statement in C or Python. So don't use exit on its own. At number 7, working storage. Hang on a second. Every COBOL programmer knows that you use working storage to declare your variables, right? Well, yeah, but that's not really quite correct. Here's the thing to remember about working storage. If you're calling a COBOL program from another COBOL program, the call program will use its variables in working storage, and then when the program returns, the working storage values are retained, which means next time you call the program, whatever values were put in working storage last time will still be there. And so a lot of programs have code in to reinitialize bits of working storage. But did you know that there's also local storage? Local storage is very similar to working storage. The main difference is that with local storage, when you call a program, the variables in local storage are initialized every time. So it's not like working storage where the values are retained. So adding all that initialization code is unnecessary. Let's see what that means. Here's a program, and it's got a working storage section. It doesn't have a local storage section. So in this program we have in working storage some variables under WSMISC. All these variables here, these variables are initialized every time this program is called because they're defined in working storage and the program needs to reinitialize them every time. If they had been defined in a local storage section, the initialize would have been unnecessary. Let me show you a local storage section. There we are. Here's a local storage section. If you were to call this program, those variables in local storage would be reinitialized every time. No need for initialize statements, and your programs would be more efficient. So make use of local storage sections. Another thing to note here is if your program isn't being called from another COBOL program, if it's the top level program, there's no need for a working storage section at all. You only need the local storage section. So take advantage of local storage. Cut out those unnecessary initializes and your programs will run more efficiently. At number 6, comp. If you need to compile your code using IBM COBOL, you can skip this one. But if you're using Microfocus COBOL or GNU COBOL, comp is something to avoid. There are more mnemonic, meaningful keywords you can use in place of the comp keywords when you're declaring variables using pick clauses. Take a look at this table. You can see here that many of the comp style declarations can be replaced with pick 9, length, and then the binary keyword, which makes it clear that this is a binary variable, such as a binary integer. Or you can replace comp3, comp6 with packed decimal, which makes it clear that this variable is packed decimal. Or you can omit pick completely and just use shorthand terms like unsigned short, binary char, float long, and so on. You might want to pause this video and just take a screenshot of this table. Let's see what that looks like in practice. Up here we have subscripts declared, and they're declared using the keyword binary long. That makes it clear that these subscripts are 64-bit signed long integers, and that the variables declared under filler lower down are also binary long, so also 64-bit signed binary integers. Very clear, no ambiguity, no trying to figure out what comp means. So if you can, ditch the comp. At number 5, through in the procedure division. If you're using through in the procedure division to perform a range of paragraphs, that implies you're going to call a routine inside your program and then drop out of another routine, or it means you're going to group a bunch of paragraphs together and jump around between paragraphs using goto statements. Kind of like this. If you look at this code, on the left we're using the through clause to perform a range of paragraphs, and it's not necessary anymore. Why? Because in good structured programming, when you enter a routine, you exit the same routine. Through implies you're going to run on through to another routine and exit from another routine. On the right, the code has been cleaned up. The throughs have been taken out, and the 1000 initialize and 2000 load fun menu paragraphs have been rewritten so that you enter at the top and exit at the bottom. And if you need to get out of the paragraph early, like at line 116, instead of using goto to go to the next paragraph, you just exit the paragraph. And that is a much cleaner way of writing your code. So please ditch through. At 4, goto. Well, do I really have to say anything about goto? Here's an example of how goto is often used in older COBOL programs. Look at this bunch of paragraphs. They're most likely invoked by a perform to perform 4000 get username through to 4000 exit. And what happens inside there? You're basically implementing a loop that goes round and round until some condition is met, and then you jump out of the loop and exit the range of paragraphs. But this is no longer considered good practice. It's not proper structured programming. A better way is to use perform loops with the exit perform and exit perform cycle statements. Actually, if you look at this code more closely, you'll see it gets stuck in an infinite loop anyway. So goto, bad practice. It's bad practice everywhere, and it's no longer needed in COBOL. At 3, next sentence. Wow. Next sentence is like an implicit goto, which assumes that somewhere in your code, in a paragraph, there's a period which tells next sentence where to go. Let me show you what I mean. Look at this code in the red box. You'll see at line 376 there's a next sentence. What this next sentence does is it jumps to line 384 where there's a move statement. And for this code to work correctly, line 382 must end with a period. But suppose somebody does maintenance on the code, because in modern COBOL, periods at the end of statements are optional, then that breaks your code. A much better way to write the code is to assume that there are no periods inside your paragraph, except for the one at the very end. So when you rewrite the code, the next sentence isn't necessary because control will drop from line 375 in the yellow box down to the line after the end if at line 381 anyway. So you then move on to the move statements. No issues with the code breaking if somebody removes the period. If you need to break out of the paragraph, as in line 379 and 380, just use an exit paragraph statement. Next sentence makes your code brittle. Somebody removing a period unexpectedly will break your code. So never use next sentence. Not many more to go now. Here's number 2, optional periods. In older versions of COBOL, it was commonplace to use periods to terminate statements. However, in modern COBOL, this is not only not necessary, it's no longer desirable. So if you're of the mindset that every statement in COBOL has to be terminated with a period, it's time to give your head a wobble. Let me show you why. Look at the code on the left. At line 226, you've got an if statement. And inside the if statement, you've got a goto statement and then a period. And what that period does is it not only terminates the goto statement, it terminates the if above it. It gets even more freaky if you go down to line 229, because if you look at the code between lines 229 and 240, you've got all these statements including 3 levels of if, and at the end of it at line 240 a single period, and that single period terminates all 3 ifs. Now just stop and think about this for a minute. If you were to go and make a change to this code and you either took a period out or put a period in, you will break the logical flow in this code. Another thing to note here is that at line 245, the only way we're able to break out of the if, because we terminated 2 levels of if with 1 period, is to use a next sentence statement. We've already talked about next sentence statements, haven't we? So let's look at a better way to write this code. Look at the code on the right. The only period in this paragraph that you're looking at is the one at line 255, which ends the paragraph. There are no other periods. To terminate our if statements, we use the end if statement. And what this means is that we can write code that reads much better and is much more resilient to changes. Statements like end if and end perform have been around since the mid-1980s, so there is no excuse not to use them nowadays. And we can ditch the next sentence and go to statements from the left-hand side by using exit statements. In this case, exit paragraph. So the general rule now is when you write a paragraph, the only period you should have after the paragraph header is the period at the end of the paragraph. There should be no periods terminating statements inside the paragraph. That will create a maintenance headache and you really should not be doing it anymore. And finally, at the top of the pile, number 1, line numbers. What are line numbers? Take a look at its code again. You'll notice that in columns 1 to 6 along here on the left hand side that there are line numbers. Columns 1 to 6 in a COBOL program nowadays might be used for line numbers, but should really be left blank. There should be nothing in them at all except spaces. Why? Let me show you. Line numbers were essential back in the days when you wrote your code on things like this, using things like this, and then stored them in things like this. If your source file was in the form of a box of punch cards, it was absolutely essential to use columns 1 to 6 for line numbering. Why? Just stop and think for a minute. Suppose you accidentally dropped the box. Whoops. But punch cards haven't been used for 60 years now. These days we use text editors, and so there's no longer a need to worry about source lines getting out of order in a file. The text editor and the file system maintain the order of the lines of code in your source file. You don't have to do anything to protect the order anymore. And just to note, nowadays it is very common to maintain versions of your source code in a version control system such as Git. And when you check your code into source control, it is quite common in many installations to do a comparison between the new version of code you're checking in and the current version that's in production. If you are maintaining line numbers, those line numbers will show up in the difference report and create havoc with the difference report because all the line numbers will be out of sync in the two versions. It's much better to leave the line numbers out so that when you do the difference report, you see the actual differences between the old and new versions of code. So line numbers, time to let go of them.
So those are some of the deadly sins. Can you think of any more? Yeah? Let me know in the comments below. In the meantime, if you enjoyed this video, please like, subscribe, share, tell your friends, and let's learn together and carry on coding. Thanks for watching. Take care everybody. Bye for now.